This is problem number 4, and you're given an equation. You're asked which of these points, there are 6 points here, which of these points lie on a line that is a graph of this equation. In other words, which of these points are solutions to this equation. So I'm going to approach this 2 different ways. One is if I'm going to plot these points. So the word is plot, P-L-O-T. So when I place these points on a coordinate grid or a coordinate plane, that is called plotting the points or graphing the points. So I'm going to put all 6 of these points on this grid. I'm going to plot them or graph them. Then I'm going to look to see which of these points fall on a straight line. Now you can draw a straight line between any 2 points, but is there a line that you can draw through more than 2 of the points? And in fact there is. This line you can draw through 4 of the points. So then if I can write the equation for this line and match that to this equation, then that says that they are equal. They are both equations for this line. So all 4 of these points then lie on the graph of this equation. All 4 points lie on the graph of, on the equation of the graph of this line. The question is it the same equation as this equation over here? All right, so the idea is to get both of these equations, the equation for this line and the equation that's given to you in this form, y equals mx plus b. And remember, m is the slope of the line and b is where it crosses the y-axis, called the y-intercept. So the first thing I can see easily is that the y-intercept is at -3. So you go from 0 to -3. So this point is 0, -3. So the y-intercept is -3. So I can replace b with -3 right here. So now if I can just figure out the slope, then I have the equation for the line. Well, the slope is how much there is a vertical change compared to a horizontal change. In other words, for every unit that this changes in the horizontal direction, how many units are changed in the vertical direction? So that's the change in y divided by the change in x. So in this case, it's 4 units in the y direction divided by 1 unit in the x direction. So 4 divided by 1 is 4. If I go over 2 units, then there's an 8 unit change in the y direction. So 8 divided by 2 is 4. If I go over 3 units, 1, 2, 3, then there's a 12 unit change. 4, 8, 12. 12 divided by 4, 12 divided by 3 is 4. So in each case, as you divide the change in the y direction by the change in the x direction, you get an answer of 4, which means for every single unit change in the x direction, there's a 4 unit change in the y direction. So 1, 4, 1, 4, 1, 4. So it's 4 divided by 1, 4 divided by 1, and 4 divided by 1. So the slope is 4. So the equation for this line is y equals 4x plus -3. So if you're going to graph this line, you place the point at -3 and then just figure out a slope of 4. So you go over 1 point up 4, or 1 unit up 4, and you get this same line. Now, this looks pretty good. Here's 4x, here's 4x, here's a 3. This is -3, and here's a y, and here's a y. So we'll see if we can work with this equation now and get this in the same form as this equation. So I'm going to rewrite this y. This is subtracting a positive y. So I'm going to rewrite subtraction as addition. It's always a good thing to do. Rewrite the operation of subtraction as addition. So you would use the additive inverse. So the additive inverse of a positive y is -y. So now if I want to get rid of that, which I do, I want to actually get the y over on this side. I want to get the y as a positive, a positive y. So I'm going to move it over here. So I'm going to add a positive y to this negative y. That becomes 0. So what I'm doing is using the additive inverse now. So y plus a negative y plus a positive y equals 0. But you also have to add that positive y to this side. So this becomes 3 plus positive y. This becomes 0. So now we have 4x equals 3 plus a positive y. All right, so I have positive y here, a positive y here. 4x is on this side, 4x is on the opposite side here, and now it's just this -3 and this +3. So if I move this +3 over to the left side, so I have, right here I have a positive y plus 3 equals 4x. That means that 4x is y plus positive 3. So y is going to be 4x minus that 3. So I have to take that 3 away or add a -3. So a positive 3 plus a -3, this becomes 0. So I'm going to add the additive inverse. And so on this left side, then you end up with 4x plus -3. So positive 3 plus a -3, add the additive inverse, and that -3, then you have to also add to the left side. So these two equations are equal. They're just switched. The y is on the right side, the y is on the left side. This is the same as this part. So you can take them and switch them over the equal sign, and they are the same equation. So that proves that these 4 points lie on a graph of this line, and they are solutions to this equation. So now what we can do is take each of these points, so A, C, D, and E, A, C, D, and E, and plug each of those points into this equation and see if they in fact do equal 3 on the left side, which is what the right side is equal to. So for A, this is 4 times -1, so x is -1, minus y, which is -7. So you replace those coordinates, and you end up with a -4. 4 times -1 is -4 plus a +7. So this is the inverse operation and the additive inverse. So I'm changing it to adding the additive inverse. So inverse and inverse. So the inverse operation, the additive inverse, is a -4 plus a +7, and that equals 3. So 7 minus 4, you find the difference of the absolute values. 7 minus 4 is 3, and there are more positives, so this ends up being a +3 right here. So 3 equals 3. So A is in fact a solution. B is not. So when we figure this out, we should end up with something other than 3. So 4 times 0 minus 3, so y is 3. 4 times 0 is 0, plus a -3. So you add a -3, that equals -3. Well, -3 does not equal 3. So this one does not work. C, 4 times 3/4. So x is equal to 3/4, y is equal to 0. So 4 times 3/4 minus 0, so y is 0. So 4 times 3/4 is 3. These 4's cancel out. You're left with the 3. 4 times 3/4 is 3 minus 0. Well, 3 minus 0 is 3. So 3 equals 3. So C works. D, 4 times 1 minus 1. Y is equal to 1. X is equal to 1. 4 times 1 is 4. Minus 1 is 3. So D works. 3 equals 3. E, 4 times 2. X is 2. Minus 5. Y is 5. 4 times 2 is 8. Minus 5 equals 3. 3 equals 3. E works. And F, of course, does not work. X equals 4. 4 times 4 is 16. Minus y is -1. Minus a -1, so that's the same as adding. Inverse operation is addition. Additive inverse is a +1. 16 plus a +1 is 17. 17 does not equal 3. So F does not work. So we showed which of these points are solutions to this equation, or lie on the graph, the line of this equation, by showing that this equation is equal to the equation for this line, and also we plugged each of the x coordinates and y coordinates into the equation and proved that they are equal to 3.